Alright everybody, so we're going to be doing the last couple of questions for the notes for day 16 of geometry. And so we're going to do example 2 and a monitoring progress. So example 2 says writing a plan for a coordinate proof. Now the cool thing about writing plans for the proofs is that we don't actually have to solve anything. We just have to plan for the proof. Right? So let's see how that would work. So this says write a plan to prove that the segment SO bisects angle PSR. And so we want to prove that this ray here, SO, is cutting this angle right here perfectly in half in two equal lengths. And so what are we given? So we are only giving the coordinates of the vertices, right? So if you notice, we are given P, O, R, and S, and we are given the number of these coordinates. And so we want to prove that that segment is going to split that triangle, or sorry, that angle in half. So let's see. If we want to prove that two triangles are congruent, we can start by finding out what the length of each of these sides is. Again, we don't have to actually calculate these, but here is our plan. So we're going to use the distance formula. So we're going to use the distance formula to find the side lengths. To find side lengths of triangle POS and triangle ROS. Right, so if we do that, you're going to notice that all of the sides are actually going to be congruent. Right, so then after using the distance formula, we figure out that this length and this length and this length right here have to be congruent. So once you know that all of the sides are congruent, we can say by side theorem, triangle POS is congruent to triangle ROS. And so because we know that these sides are equal, and then this side is being used by both triangles, that's how we know that all three sides are congruent. And so POS is the triangle on the left and ROS is the triangle on the right. And so because both of these triangles are congruent, we can say by CP/CTC. Remember, we don't want to write that whole thing, but by the congruence property of congruous triangles are congruent. The congruent parts of congruent triangles are congruent. We know that angle PSO has to be congruent to triangle, to angle RSO. And because angle PSO is this one right here, and angle RSO is this one right here, because we now know that these both measure the same thing, we can conclude that the segment SO, the ray SO bisects angle PSR. So again, notice how we didn't do any math. We didn't calculate the distance formula. We were just doing this as a plan. And so we are going to do the exact same thing for the monitoring progress example. Right, and so once again it says write a plan for the proof, so we don't have to solve this out, but we do have to build a plan so that we know that those triangles are going to be sorry, not the triangles that these two triangles are going to be congruent. So what are we given? We are given that ray GJ bisects angle OGH. So in other words, this line right there, GJ, bisects OG and H. And so once again, just like in the first example, because we have a bisect of an angle, we know that this angle right here and this angle right here have to be congruent. Right, so that's the very first thing that we figured out. Those two angles are congruent. And so now let's see if we can build this plan for the proof. So once again, we want to figure out whether these two triangles share a side. So what we're going to do is we're going to use distance formula to find the measurement of GO and the measurement of GH. Right, so GO is this one, GH is this one, and if we can prove that, if we solve this and we can see that they have the same measurement, then we can say that GO is congruent to GH. Right, so if we do that, we now have one side, we have an angle, and if we are able to find another side, then we can use side angle side in order to prove this proof right here. But in fact, we already know that we do have those two triangles, right? And so by given, we have to deduce that angles OGJ is congruent to angle HGJ. And so again, we have a side, we have an angle. All we need now is another side, and if we pay close attention, by the reflexive property, GJ is actually being used in both triangles. So we can say by reflexive property, property of congruence, we have that GJ is congruent to GJ because they are the same line. And so now we can finalize this proof, or the plan of the proof, by saying that by SAS theorem, we now know that triangles GJO has to be congruent to triangle GJH.